Hello everyone. In this video, we will learn about a family of functions called partial fractions. And then we will discuss about why these functions are important for us. This video is an overview of how partial fractions can be used to integrate rational functions. Let us start with rational functions. What are rational functions? Rational functions are functions of the form p over q, where p and q are polynomials. In other words, while you have some multiples, numbers multiply some powers of x added in the numerator, and some constants multiplied positive integer powers of x and added, that's the denominator. Something like, e.g., something like, say this one, x cubed minus 3x squared plus 3x plus 4 over x squared minus x minus 2. Or something like 2x over x squared minus 1. So these are examples of rational functions. But out of this family, there is a family that is going to be very important for us. It's called partial fractions. What are partial fractions? Partial fractions are rational functions, but we only consider very specific form. Rational functions of the form. So, very special cases. When you have a number over ax plus b to the power j, or we have ax plus b in the numerator, and in the denominator we have ax squared plus bx plus c to the power j. Here a and b, so a, b, c are constants, and j is a positive, and j is a positive integer. For the second part, I will specifically force that the ax squared plus bx plus b is irreducible. Or in other words, I'm assuming that b squared minus 4ac is negative. Well, there's a condition there. I would like to say it at least once you see it, but then later on we will come back and see why that's important. Well, sometimes you will see me calling these ones powers of linear, and I mean partial fractions with powers of linear in the denominator, and these ones I will call them powers of quadratic. In other words, partial fractions with powers of quadratic in the denominator. Okay, well, let's see some examples of this. For example, we can have something like, say, 1 over x plus 1. Yeah, that's the simple case. Or we can have, say, 3 over 2x minus 1 to the power 5. Yeah. Or the quadratic form, the powers of quadratic form, it could be something like 3x minus 1 over x squared plus 2x plus 5, or any powers of that, okay? So you say, okay, why these class, why are partial fractions important? Why on earth we choose this specific family, and why these are important for us here in Calculus 1301, okay? So the first thing, which is very mathematical statement, actually combining several things, you can see that every rational function P over Q can be written as, okay, so I can do every rational function as this. I will write two pieces for that. Any rational function you give me, I can do this. First part, it's going to be a polynomial, so I'll just write Sx, a polynomial. And then another piece, which will be sums of partial fractions. Okay, so we may have 2 terms, 10 terms, only 1 term. So we can write every given rational function as sums of two things. One, a polynomial, and the other one, sums of partial fraction. This other side, we call it partial fraction decomposition. And well, for example, let me at least show you an example here how we will write that. That's another thing that we will discuss in another video. But the example that we had at the beginning, x cubed minus 3x squared plus 3x plus 4 over x squared minus x minus 2 can be written as x minus 2 plus 1 over x plus 1 plus 2 over x minus 2. As you see, this is the polynomial part, and this one is the partial fraction decomposition, or the partial fraction part, sums of partial fractions. How did I do that? This is one of the goals of this section, that we will learn how to decompose and write that equality there. But let me just give you at least one piece of information. I already given you one terminology, partial fraction decomposition. That's something that we will work on, and it's very important. But this first part is also something that we will get from what's called long division. So we will use long division to turn our rational function to a polynomial plus what's called proper rational function, where the degree of the numerator is less than degree of the denominator. And then there's a trick called partial fraction decomposition, that then using that we can find this partial fractions, that when you add them you get that piece. Okay, so you said that's very nice, you do all these works, but why? Look, integrating polynomials are easy. If I know how to integrate partial fractions, I can claim that I I can integrate all rational functions. Again, I know how to integrate polynomials. If I know how to integrate partial fractions, then each piece I can integrate and add them. That would be integral of the rational function on the left hand side. So I can use partial fraction decomposition to integrate any given rational function. So that's the key point for us, why it is important for us because we will learn first how to integrate partial fractions, and then using that we can integrate all rational functions. And isn't this the goal of the 1301, the chapter Techniques of Integration? That's why it's important, and in next videos you will see how we do the decomposition, how we integrate partial fractions, and so on.